We can start, Umashankar.
Are you ready for the healthcare event of the year? Stay tuned for the new era of patient safety and technology in healthcare, being hosted by Apollo.
Good afternoon, Namaste. Welcome all participants for today's session on green hospital, sustainable hospital, and human-friendly things. So today we have two experts who are talking about green hospitals and sustainable environmental solutions for hospitals. The concept related to green health and green hospitals are rapidly changing and varying their scope towards wider perspectives. On one hand, impact of building design, construction, operations, and management of hospitals of environment and healthcare are currently accepted. On the other hand, hospitals are complex systems where changes are neither fast nor easily performed. In order to achieve green healthcare system, a deep knowledge of its strengths, weaknesses is needed, as well as of the internal dynamics. As we move forward into the 21st century, there are growing realization that the relationship between humans and the wider environment is crucially important. And recognition that unrestricted globalization linked to an increasingly dominant consumer culture has wrought devastating impact. Within its context and catalyzed particularly by concern about climate change, there has also been increased appreciation that public health and health of planet are closely interrelated. How does a hospital sustain its journey towards environmental sustainability? To date, most hospitals have embarked on some strategies for improving environmental performances, whether it's reducing energy or landfill waste. Environmental sustainability strategies, however, can often lose momentum or stagnate it, not championed by someone whose full-time role is to assess, monitor, and bring new strategies on the table. In the face of ongoing budget deficits, it is increasingly difficult to get adequate support and buy-in for this type of role unless the leadership of the organization is committed to an environmental sustainability program. To talk on this topic, we call our first speaker for today. So, Mr. Vinod Kumar KB. I think he needs no introduction, but I would still take my privilege to introduce him for all of you. So he is graduated from PSC College of Technology. He's a mechanical engineer. He has over 3 decades of experience in engineering, with over a decade of experience in healthcare engineering, especially. So his experience in engineering design, engineering system implementation, and in quality and safety in facility management systems, including hospital patient safety, is known to all of us. He is currently the chairperson of Engineering Forum of Healthcare at CAHO, which is Consortium of Accredited Healthcare Organization. He is also a facility management consultant at Rajgiri Hospital, Aluva, so which is a beautiful facility. I must acknowledge that I have been visualized this particular hospital, and it is fantastically maintained by him. So he is also a facility consultant and managing partner at VBG Consulting Engineering Group. So he's also a member of ISRE of Kochi chapter. He's a vice chair for Focus. He's a member of FSCI. He is IGBC accredited professional. He is also an assessor for AACI, American Accreditation Commission International. So if I keep talking, the list will go on. So I would leave the session to you, sir. Over to you. Please start your session.
Oh, awesome, Dr. Umashankar. Thanks for that introduction. It was so great. And thanks to the management at Apollo for giving me this opportunity to speak on this 11th International Patient Safety Conference webinar series on sustainability and green hospitals. Thank you, Dr. Uma, and thank you, Dr. Sanjay, for giving me this opportunity. And welcome to all the participants. And we have half an hour to 40 minutes for my session, followed by Thorasina themselves will speak. So let me start sharing.
Yes, sir. Go ahead.
Good afternoon once again. So let's start with what is a climate smart hospital? That is what we should dream about our hospital. That's the need of the hour too, because they generate minimal amounts of greenhouse gas. It puts the healthcare system on a climate smart development path. It also aligns the healthcare development and delivery in line with the global climate goals, and it also saves money for us. So we should always try, or we should always work towards making a smart hospital, which is a climate smart hospital. But where are the challenges? The challenges are too many. We need to look at where we are in terms of energy consumption. And if you look at the energy consumption as per the charts that you see in front of you, we use a lot of electricity in terms of fuel or in terms of energy that needs to run a hospital on a daily basis. Looking at a World Bank report, which is co-produced with Healthcare Without Harm, that's what the motto is as a doctor is concerned, or as a healthcare organization is concerned. It establishes a new approach. What it says, that which bridges the divide between adaptation and mitigation in the healthcare sector. We need to adapt ourselves. We need to find out mitigation measures to bridge the gap. We have gone so far away in terms of carbon footprint as far as healthcare is concerned. We need to bridge that gap. So what are the risks and how do we look at what are the challenges or what is the way to approach and make a hospital as a climate smart hospital? We need to start with the design of the hospital, which need to be a climate smart design. We need to build it, implementation of the construction, implementation of the systems, and to make a building, which is the healthcare building organization. So that has to be also with the same approach of a climate smart healthcare. And then after all this, if we don't operate it very well, we will not get the intent that was made in the design stage or that was made at the implementation stage. So we need to operate it. And finally, you need money. You need to invest in proper healthcare systems and healthcare facilities, which makes the hospital a climate smart healthcare system. Look at the pie diagram. You can see that air conditioning becomes the largest power consumer, but without air conditioning systems, we can't run the hospital. So obviously, how are we going to approach to make this a climate smart system? Now we have lots of risks and we have lots of opportunities also. Where are the risks and what are the opportunities and how do I recommend it? Let's start with the design stage. If we do energy modeling of a building straight away, before even you start the construction, then you are going to have an energy efficient building. Energy modeling is supposed to be done straight away, which actually guides you to make the building energy efficient. Also, go for preferably a system of purchasing the right product which are energy efficient. At the same time, which will lead to less cost of energy when they are high energy efficient systems. So this will obviously make you to apply for or getting a certification on green building. So energy modeling to be aligned at the design stage itself for higher efficiencies in energy levels. The next comes the operation and maintenance. When we look at a building, the condition is that people who are actually running the building or operating or maintaining it, they lack awareness. They just have to run. They are all taught to run the system to give the critical requirements in the building, like water supply, air conditioning, whatever be the energy, whatever be the utility in the system. But are we able to see the risk? Are we able to identify where things are going wrong? We don't. We may not. We don't have the expertise in the operation maintenance field as well. So what are the opportunities? The opportunity lies in first of all identifying where the energy consumption is, monitoring them, conducting awareness among the staff to see that they need to monitor it, and do energy audits, and then implement the findings of all the audits to see that to bring down the energy consumption gradually during the operation and implementation, operation and maintenance phase of the building. So you can see where we have lots of opportunities to make the system a climate smart system. Now let's look at some of the information that we have gathered. The climate impact on a hospital cooling is significant and is always on the rise. Globally, roughly 365 metric ton of CO2 is being pumped into the system, into the environment because of the air conditioning system, which is equivalent to the emissions from over 75 million cars on the road or even 110 coal power plants for an entire year. So you can imagine what is the level of our carbon footprint in terms of healthcare system alone. I'm just talking about the challenge in front of us. Can we live without air conditioning? We can't. So how do we look at it? Okay, if we don't think about measures to bring that under control, if you don't bring this to the attention of all our healthcare workers in the building, if you don't bring in systems which are energy efficient, then you can imagine by 2040, this particular carbon dioxide emission is going to be 4 times. Can you imagine? We are going to be damaging the earth much, much higher than what we can ever think of. So as for the opportunities that we have in healthcare, we need to always find out the availability of energy efficient systems. Low global warming coolants, which are used in the systems, which are the air conditioners, chillers, refrigerators, etc. We need to bring in innovative design like passive cooling and ventilation, improve the ventilation and conditioning systems, and also try an approach to reduce the cooling load. Because, for example, in a hospital, we bring in a lot of fresh air. At the same time, we exhaust a lot of air which is conditioned. So can we capture the waste coal that is going into the atmosphere? Do automation, building management systems to bring in possible methodology which is automatic, at the same time reduce the cooling load, bring the cooling load as per the requirements only for the critical areas, bring in all the waste cold and cool the fresh air that is coming in as hot into the building. So you can see that there are various opportunities that we can do. And this can be done not only in the initial design stage, but it has to be done continuously throughout the process, throughout the time the healthcare is functioning, and go for on-site or off-site renewable power resources rather than depending upon the state electricity board power supply. Now, I think most of you know what greenhouse gas emissions are. These are the gases that have very high global warming potential. They can contribute to the heating of the atmosphere, as a result of which there is always an ever-increasing temperature rise on an annual basis, leading to a climate warming, what you call it, global warming risk. Its impact is not only on the increase in temperature, it also increases the or brings in untimely rains. It also leads to huge melting of the glaciers and ice caps, increase in the sea levels, and various other global warming changes that is really becoming a botheration to the entire world and the environment. So now, where are we in terms of the healthcare industry, in terms of our contribution to the CO2 levels that is ever increasing from the healthcare sector? We have to talk about 3 scopes: Scope 1, Scope 2, and Scope 3. Scope 1 is a direct emission from the hospital. Scope 2 is the kind of products that come into the system, including the electricity that we take, including the transportation that is needed for bringing in the various requirements to the building, the employees that are commuting from their homes to the hospital, the goods that you purchase from the various industries to run the hospital, all those form Scope 2, and that is the upstream activity. And then the downstream is what we contribute post the operations from the hospital. Again, transportation, processing of all our biomedical waste, a lot of waste that we generate, and we also have a lot of assets which we need to maintain, and the cost for maintaining such buildings all become a Scope 3 or indirect or downstream activity. This is a big subject to understand, but at least I'll touch upon where this particular energy consumption or our contribution to the levels of environmental damage is actually happening. Now, Scope 1, as I said, is direct emissions. Scope 2 is electricity and the transportation that brings in all the products that you need to run the hospital. I can say if you have a water problem, tankers will come in. That is a transport. People will come to the office from their homes. People will go back to their homes. Materials will be delivered to your stores. That gets transported from various parts of the country or the state, comes in. So these are the ways that you actually look at Scope 1, 2, and 3 and identify, because it's not only you as an emission of carbon, but you have the upstream and downstream that also needs to be controlled so that the overall control can be brought down. I hope it's clear. So the combination of scope 1, 2, and 3 as part of the entire supply chain management totally will bring in this control on this global net emissions, which is coming from the healthcare's carbon footprint. Now, another important status on the global status, which I would like to talk about is healthcare is one of the most trusted and respected sections of society, but it's also one of the largest employers and at the same time consumes energy, which is very, very, very high. So this global healthcare climate footprint is equivalent to the annual green gas emissions from almost 514 coal-fired plants. This report is basically taken up in 2019. Now, this carbon footprint is an indicator of the amount of the greenhouse gas emission status from the hospital. So we have to do a calculation. We need to have a separate team. We need to aspire to make the hospital global carbon neutral. How do we do it? Look at the major organizations that we see around us. Amazon, Microsoft, Volvo's, Tata's, all of them have a committee to run their systems to calculate, to see where they are in terms of their carbon emissions and work towards carbon neutral. So why I brought this point is we need to have a team. We need to aspire to become carbon neutral. That way we become a responsible business system. Now, coming to the action plan, as I said before, I did touch upon this in one of the previous slides. We need to have a proper design stage to plan the entire scope, not only the hospital, the upstream activities as well as the downstream activities. And when you work on the total supply chain management as an entirety, you will look forward to becoming a green certified building, explore all the kinds of renewable sources, energy sources that you can pick out and work on to meet your demands on a daily basis for the hospital's requirements. Coming to post-design stage, it's the operational maintenance phase. Here again, we need to see where we are going in terms of our greenhouse gas emissions during the operation phase. So we need to have the right team to see, to identify where what are the greenhouse gas emissions, monitor them, find out methods to identify. So basically, as I said, this committee who drives this particular, going carbon neutral has to take care of this entire operations of bringing it carbon neutral. At the same time, getting alongside the entire hospital healthcare system, including the staff and the systems, to make sure that they are all working towards the same kind of goal. Similarly, for example, in B talks about anesthetic gas and its potential of this climate change. So we need to also make sure how do we handle the anesthetic gas as well. So it's important to have a vision, a plan, developed a committee and team members who are knowledgeable in the whole process of controlling the carbon emission from the hospital, without which I don't think we can ever achieve any kind of levels that the government or the world or WHO is looking for from the healthcare sector. Now, when it comes to the water usage, we did talk about electricity. Coming to the water usage, we are a very water intensive organization. We use, like, as per the international standards, you know very well that we need only 450 liters per patient per day. Considering the use of a kitchen or a laundry or a CHST, the consumption may go up to 500, 600, or let's see, to 750 to 800 liters per patient per day. But you can very well check on your current water consumption. It generally goes beyond 900 to 1,000 liters per day. It's basically a very large consumption of water, and of which 80% comes back as wastewater, which finally lands up in the STP or the sewage treatment plant for water treatment. Now, let's look at the global and local scenario. There is very less surface water, hardly 0.03%, and that is now getting polluted because we put almost 60% of the sewage gets drained into the rivers. And when you look at the water quality index in the world, among 122 countries, we are at 120, a very low level of position in the case of availability of clean and sufficient water. So you can imagine we are damaging the water resources, but we need water as well. So what happens to that? We take this unclean unclean water, which is unsafe, and we then spend on treating the water. So you can imagine you are unnecessarily increasing the cost as well, because you need to treat all this water, because you need this much water, close to 1,000 liters per patient per day. So if you have a 500 bedded hospital, you need 5 lakh liters on a daily basis to operate the building. So what can we do looking at the global scenario? Please conserve this precious natural resource by closely monitoring the water use. How can you monitor this? We put water meters at all the end users in the system, like cooling towers in the air conditioning plant, like the like the kitchen, like the laundry, CSSD, wherever water usage is there, please put in water meters, closely monitor them. Change all the leaking fixtures, go for water efficient fixtures, use the latest technology, grow drought resistant plants. We have various methods that can be utilized to reduce the dependence on this water. At the same time, you use good water and also be releasing less water into the STP as well. Reduce the usage of water or use it correctly or aptly is what I would like to say. Looking at this global scenario, we need to work a lot towards bringing this into a state where we have a good control on the water usage. These are some of the methods that we can bring in to reduce the water usage, at the same time not affecting the efficiency of the water velocity or the flushing velocity, or even controlling the water pressure under the shaft. So various fixtures are available. So even it's an old building or a new building, always keep working on how you can reduce the water consumption per fixture, per zone, per floor, and the entire hospital in total. The other method is to reuse the treated water from the STP. Where can we use them? We can use them for horticulture, landscaping, for all your flushing activities, and for also the cooling tower makeup systems. Now, there are other methods that we have to utilize is that water meters I did mention, rainwater harvesting, and also use all the water that possible for that can be reused from your STP. At the same time, AC condensate drain reject water. There's a lot of water that keeps coming out of the buildings usage. Check the water qualities and utilize them within the building. Zero waste is what we need to look at. Coming to hot water generation. See, we have various methods of using systems that can actually heat up the water for our hot water requirements. We have boilers. Boilers use wood, diesel, or gas. Some of them use electricity. We have solar systems. We have heat pumps, and now we have hybrid systems which have solar and heat pumps together. All these equipments have various advantages, but you can look at the life cycle. You can look at the safety standards, how hazardous they are. But when it comes to the safety and the lifespan, basically the heat pumps and the solar systems are generally better in comparison to the older method of using boilers for water heating. So you have to keep changing the older systems to better systems which are higher efficient and which have a longer lifespan. I did forget to talk about an important word. Whenever you buy a product which is energy efficient, please also check on the lifespan of each equipment and look at the return of investment on those equipments in comparison to shorter span equipments or low energy efficient equipments, which are less investment intensive. I hope you understand that. So I did mention initially we need to invest, but the investment definitely will look at a good ROI, which means it's going to be not only energy efficient at the same time, money saving as well. Now, we did talk about air conditioning systems, refrigerators, chillers. All of them should have the ozone-friendly refrigerant gases, namely R134A, 407, C, or R410, which are all eco-friendly and approved by the systems so that you don't have an emission because of ozone-depleting substance, which generally are the older refrigerant gases. Similarly, we use a lot of cleaning agents, and they all should be basically products which are having a green globe and certified systems. They are used for all our cleaning purposes. They should be eco-friendly and biodegradable at the same time. So make sure that your purchasing capacities, the systems are all well set up in your procurement policies so that it not only brings in green and green friendly systems, but it also safeguards and protects your housekeeping staff overall. Next comes in natural lighting. We have to make sure that when we build our organization, we need to bring in a lot of natural lighting, thereby reducing the cost of energy that we need in terms of using artificial lighting. So you look at areas like waiting areas, like the lobbies, corridors, even ICUs needs natural lighting, because there is something that a patient who comes out of his anesthesia and then starts looking at which day I am, is it night, day, or whatever it is. So basically, natural lighting brings in that kind of eco-friendly or environmental friendly systems within the hospital premises. And as you know, we need to, if you have an enclosed waiting area, air conditioning is provided generally, but we don't provide exhaust ventilation, because the waiting areas are where almost all the sick people come and sit together before they get treated. So automatically they becomes highly, the air becomes highly contaminated. It's a contaminated area basically. So ventilated areas, especially for the waiting lobbies and corridors, generally are better than providing air conditioning and then providing exhaust fans, at least with minimum 10 to 12 air changes per hour, to bring in that high amount of energy, high amount of efficiency in the air quality in the waiting area. So environmental friendly hospitals and lobbies and corridors are a part of this particular system. Coming to the major equipments, we should definitely talk about the air conditioning plant. So your selections should be that they consume power as low as 0.5 to 0.3 kilowatt per ton. Similarly, when we go into the pumps, utilize the usage of variable frequency drives, which are generally the best kind of drives that you can select for your equipments to drive the pumps and cooling towers, or even the chillers, thereby bringing in energy efficiency at the same time, safeguarding your electrical system due to the inrush currents. Coming to the other energy conservation measures that you can look at, convert to LED lights, select all your motors which are more efficient with efficiencies above 90%. We can classify the motors into IE2, IE3, IE4 categories. We also have EC motors nowadays, which are the best efficient motors currently in the market. So look at options where you upgrade your major systems with high efficient motors, which will definitely bring in large amount of power savings. And I did mention about variable frequency drives. There are systems which pump water. Make sure that you have hydropneumatic systems. And when it comes to automatic controls of the chiller plant system, we use control valves to control the chill water going into the air handling units or the fan coil units. What happens there, when the consumer asks for a temperature of 18, 19, basically we don't need 18, 19 temperatures in normal usage areas unless you have a theater which is used for neuro or ortho case. But in a normal air conditioning system, comfort applications, you don't need temperatures below 21 in any case. But you can avoid people going down with lower set points like 18 or 17 on the thermostats by using very dependable systems called the pressure independent control valves, which definitely will save up to 40% of your power because of the optimum usage of chilled water. Because you have a set point, it doesn't go below the set point. So people cannot definitely get any temperature below 20 or 21 degrees. So that itself is a huge saving to us. Heat pumps, I did mention the best efficient systems for making it an E-friendly system in comparison with your boilers or conventional geysers. And when we select other larger equipments like generators, we need to always make sure they are high efficiency, because they consume a lot of diesel by giving you less kilowatt of power into the building. So you can imagine, if you're not high efficient, then obviously you will waste a lot of money on the use of diesel to produce or generate a lot of power that's needed for the building. Another important aspect is the use of treated fresh air and handling units, which generally have heat recovery system. I did talk about waste air, which is going out of the hospital because of our extraction or ventilation, which is generally cold in temperature. Now we can actually use heat recovery wheels in the treated fresh air issues, whereby you can actually take over the chillness from the air which is being extracted outside and put it into the fresh air through heat recovery wheels. So that way you will be able to temper the temperature, temper the outside air from 40 degrees to 24, 25, 28 degrees, depending upon the selections or you are actually looking for in terms of fresh air being supplied across the building. I hope you understand we need a lot of fresh air into the hospital, because like 4 air changers in the theaters to 2 air changers in the ICUs two air changes in all occupied air zones. So in all this is outside air coming from the environment, which is dirty, which is unfiltered, which is at high temperature and high humidity. So we need air conditioning systems which will treat this fresh air before it comes in. So that's a cost of money because energy is being used up. So to reduce that energy, use the waste cold chillness going out from the extract air through the same HU, which has a heat recovery wheel. That's what I wanted to explain. I hope it is clear. Now coming to the chiller plant is the biggest energy consumer in the hospital. But what happens is you need to ensure higher and better heat transfers. To make sure of that, we should not have scaling. Whenever there is a water source, obviously scaling happens. To reduce the scaling part or the effect of scaling, we need to have tube cleaning system, automatic tube cleaning systems, which will keep on cleaning the condenser tube at regular intervals. This will keep the tubes very clean and void of any scaling, which generally gives you the better heat transfer rates. Coming to automation, the chiller plant has to be totally automated, not man-operated. What happens is the chiller plant manager knows what is the efficiency of each of the equipment and at which percentage the equipment has to be running to maintain the coolness, the temperatures in the hospital. It depends on, it doesn't compromise on the cooling, but it finds out what is the best efficiency of every chiller or the pump or the cooling tower based on the parameters it measures automatically. So it takes a lot of it keeps on monitoring the temperatures and the flow rates and the requirements, and it also has in-house inbuilt in it the efficiency levels of the systems that is running on the chiller plant manager. So knowing its efficiency, if it knows that a chiller will work very high efficient at 80% of the load, it will make sure that the chiller is always loaded to 80%. That can be done only automatically. I hope you are clear about it. A chiller plant manager is an automatic method of running the chillers. And next one is using insulation material, which have impregnated with microban, which is antimicrobial and antivirus, because any insulation material definitely will get wet. And when it is wet on a wet surface, you can have bacterial and virus growth. To bring them down, they should be repelling this growth of bacteria or virus. So that is why the microban system is to be impregnated into the insulation materials that is being used there. Other methods are variable frequency drive, I mentioned, double glazed windows, tinted windows for all the air-conditioned rooms, cooling towers. See, cooling tower is the machine which is actually dissipating the building's heat into the atmosphere. Now, if it is inefficient, your air conditioning system is inefficient. When that becomes inefficient, your electricity bills go up. So obviously, CTI certified Cooling Towers Institute, the American-based institute, you need to see that when you buy your cooling towers, they are CTI certified. Okay, that makes it very much reliable in terms of heat dissipation, in terms of energy efficiency as well. Now, we need to have a constant system of ongoing, constant education, constant checking, constant auditing. Your water quality has to be very good. You need to have the right person working to operate the various systems in the building to see that you cater to the requirements of the end users. So everybody should be taught about energy conservation. So you can imagine, just stand in front of the operation theater door and you can see how many times they open a door during a surgery. From the time the surgery starts till the time the surgery gets over, you can actually imagine the number of times the door opens. See, there is no control on it. We need to teach everyone in the healthcare system energy conservation, energy conservation, energy conservation, and keep on giving refresher trainings and also counseling your patients, because they are also part of the system. Because at the end of the day, they should also not waste our energy levels. Another point that I wanted to also talk about is we generate a lot of waste. We need to have a good control on it. We need to try and reduce to how much ever possible we generate the waste as well. So as you see, we have a lot of biomedical waste. We have systems, but having said, the right kind of segregation, the right kind of transportation, the right kind of disposal is mandatory. So if you don't have a safe practice, obviously that also comes into a cost and energy levels and also affects your environmental friendly approach to run the hospital, because we dispose one of the most dangerous waste, and that is going to be detrimental to the environment and to the society at large. So we should have a setup of very good practices in maintaining the entire waste management process. Papers and plastics and e-waste should be sent for recycling. Food waste, either you set up a biogas plant or you set it to a piggery. All the organizations' waste management should be exactly in line with the latest biomedical waste management rules and guidelines, and based on the approvals from the local or the state pollution control board. So you need to make sure that you have these systems in place, first of all, proper training to make sure that there is a track of segregation to disposal and to composting or even disposing of the waste to the main vendor who takes your biomedical waste. So make sure that your systems are in place, have a tracking method so that people do not generate more waste or people do not go for wrong segregation. All that is definitely not going to be environmental friendly. Coming to this protocols and systems, have a systematic or a strategic plan all the time and keep on developing or amending your strategic plans as the rules and guidelines keep changing, so that your handlers, the biomedical waste handlers, are knowledgeable on what's happening, and they are the people who are likely to make mistakes in the segregation or into the transportation or even into the disposal. So it's important that you have a strategic plan to handle the process and do the man management also. Similarly, you need to have a energy friendly or environmental friendly procurement policy, which should be through and throughout any kind of purchase that you're going to have in the hospital. Like having a system, suppose you buy any refrigerator or a cooler or a chiller, it should have a refrigerant gas which is not an ozone depleting substance, ODS as it is lightly called, no mercury apparatus. You need to know the lifespan of every equipment that comes into the building, because without knowing that, you will not be able to plan the condemnation. Without knowing that, you will not be able to set up your timeline for upgradation. You will not be able to set up the replacement process also. Why is that important? Because every system during its operational timeline or during its lifespan has an ability to derate or depreciate in its efficiencies. So you need to have a proper system of identifying when you need to replace a machine, or when you need to upgrade the system, or when you need to replace a part or a whole of the system to make it efficient. Because we have seen systems not being operated very well, as a result of which it is ready to get replaced. That is another issue. So having the right personnel and the right team to manage and operate the system is also important. And another part of environmental control is how do you control the indoor and outdoor environment? There is noise, there is emissions. So we need to have a proper control on both. See, like you need fresh air, but where do you take the fresh air? You take it from the atmosphere. Is it good? No, it's not good. It is high temperature, it's highly polluted. So you need to have air quality or air filtration systems to make sure that the air is filtered. Then you need to cool it. Why? Because the air is going to be very, very hot. Now you need 22 degrees in the room. The ambient temperature is 40 plus. So you need to bring it down. So you need to cool and filter. So this generally doesn't happen, because when you bring in fresh air, it's going to increase the chiller load. It's going to increase the energy consumption. So what happens is generally the fresh air stays closed, but you can't have it in a closed system. You need to have the fresh air as per the requirements of the healthcare requirements. You cannot have a bypass to that. So the only way is to keep the fresh air systems open, keep the fresh air systems properly working, so that the contamination control happens as decided and as designed. Otherwise, you're going to have contamination issues if fresh air is going to be not going to use fresh air in the hospital. Emission controls from your generators, from the incinerators and boilers also has to be in line with the pollution control board. People use efficient scrubbers also, so that your emissions into the atmosphere is acceptable as per the pollution control board limits. Awareness programs, safety week programs, you need to bring in the community, you need to bring in the patients also along with us to see that your goal of going carbon neutral definitely is going to be successful because you need everybody along with you to make that a big success. I would like to talk about important thing is a responsible approach from the organization, from a responsible approach from every healthcare worker in the organization. It's means a responsible business, which means an opportunity for boosting it with sustainable medical tourism. Thank you very much.
Thank you, sir, for enlightening us today. I think it was a very good session from you. So,
Have I short the time? 10 minutes, right?
no, you're on time, totally on time. So, as you all know that this webinar series is in continuation with our 11th International Patient Safety Conference, The Future of Patient Safety. So, please register for the conference and you will see much more things happening at that venue. So, request you all to join us at the grand event, which is one of the most happening event in our country. So for moving on to the next speaker, so we have Mr. Tulsi Nathan. He is the general manager of facilities at Apollo Hospitals, Navi Mumbai, which is a LEED Platinum rated building. So Mr. Tulsi Nathan has over 2 decades of diverse experience in handling all facilities aspects and project management aspects of healthcare and other industries. He has been working with healthcare for more than a decade. So he's worked with Apollo, MIMS, EMS, and previous hospitals. So he holds a bachelor degree in mechanical engineering to his credits. We all know that maintaining a facility which is up and running is the most challenging aspect in healthcare with stringent budgets to all of us. So with that note, I call upon Mr. Tulsi Nathan to Mr. Tulsi Nathan.
Hi, Doctor. Good afternoon.
Good afternoon.
So thanks for giving this opportunity, and Dr. Sanjay and the entire Apollo Hospital. Just thank you so much for giving this opportunity. So we will just start with our presentation.
You can share the screen.
Visible?
Yes, you can make it as slide sharing.
Yeah. So this topic is about green hospital, healthy communities, and environmental sustainability. So in this, what is meant by green hospital? So the building which uses the less power, less water, and conserve natural resources, and also generate very less waste. So this will be called as the green hospital. So in this, the very basic activity is that site selection and the planning design. So this is the very basic activity of the green building. So in this, we should ensure that, just a minute. So the site selection is a very basic activity in this. So in that, we should ensure that the selected site should be very near to the transport connectivity and easy to orient, and also the parking facility and the landscape design, everything can be arranged in the future. And also the other basic arrangement like soil testing and easy to get the power, and also the water connection, the drain connection, and easy to get the medical gases. All those arrangements need to be considered while we select the site. And before we start the site, the soil erosion control need to be taken. So before we start the site, the mother soil need to be taken and it has to be preserved. And the same soil need to be used for the gardening purpose in the future. Then the integrated design approach. So when we design the green building, the important team members like architect, MEP consultant, green building consultant, interior designer, landscape designer, structural consultant. So all this kind of team members need to be involved in this and their input need to be considered while we design the green building. Another passive architecture method need to be incorporated when we design the green building. The passive architecture in the sense, all the natural thing we have to use it when we design the green building, like orientation. When we design the building, the north and the south side of the wall area, it should be more than the east and west side of the wall area. So this will automatically reduce the heat input, the solar input into the building. Also the sky lighting. So we should ensure that the maximum amount of sky lighting, we are getting it on an automatic basis. So this will reduce our lighting load within the building. And also the shade from trees and adjacent building and vertical and horizontal landscaping, etc. need to be considered. So this also will reduce the heat input into the building and through which we can reduce the heat load within the hospital building. And also the wind tower technology can be used to get the automatic and the natural cooling and heating of the building. So through this way, by using the passive architecture method, we can reduce the heat load within the hospital building. Value-added services. When we select the service, when we select the hospital building site location, we should ensure that the value-added services like pharmacy, cafeteria, fitness house, library, ATM, family restaurant, and park, it's all there within the just in a walkable distance, so that the people will not be using the automobiles vehicle, so that they will try to go by walk. And this can reduce the negative impact caused from the automobile. Proximity to public transport. So when we select the hospital site, we should ensure that the main bus stand and railway station, it's all there in the walkable distance from the hospital location. So again, this will reduce the negative impact caused from the automobile use. And low emitting vehicles. When we design the car park area, we should consider that we have to install a lot amount of electric charging point to charge the electric vehicles. And again, this will indirectly, it will promote to use the electric based vehicle. And this also will reduce the negative impact caused from the fossil fuel used automobile vehicles. Heat island reduction. So in this, when we design the car park area, it has to be like a covered car parking need to be selected in general. And also that roof area need to be have with high reflective materials, and also the garden need to be considered to reduce the heat island. Then while we execute the job, we should ensure that the basic facilities for the construction workers are being given. So like additional, the required amount of housing arrangement for them to stay, and the proper toilet facility, urinal, and the drinking water facility, the proper PPEs, and the first aid arrangement, then the dust control, also the proper illumination, and for the kids, we have to give the creche arrangement. So all the things need to be given for the workers to do their work properly and also safely. Universal design. So the hospital design should be user-friendly for the differently abled and for the senior citizens. So in this, we have to consider the separate car parking for the differently abled people. So this car parking can be adjusted to the lift, or else it can be adjusted to the entry or just near to the exit for them to use this, the car park area so easily. And also the lift for them to use it very easily, that arrangement need to be done, and easy access to the main entrance, and then the proper ramp arrangement need to be given. And the braille and then audio assistant has to be given for them to use the lift properly. And then for the differently abled people, we have to give the proper the restroom, same with the grabber, and also with the proper arrangement of the wash basin with the lower height, and also with the nurse call arrangement. All the things has to be given, and the proper walkway and the visual warnings, etc., need to be given for them to use this properly. And the building materials and resources. So in this handling of waste materials during the construction. So when we construct, there will be a lot amount of waste materials will be generated, and this waste material should not be sent for the landfill. We should try to use this all this waste material within the hospital or else it has to be sent for the recycling purpose. You can see in the attachment, the waste steel reused for the main bus. So when we construct and then when we cut the steel, there will be a lot amount of waste steel will be there. So this can be used to do the main bar construction work. Also, you can just see the used cement bags, etc. has been stored to send it for the recycling purpose. Sustainable building materials. So when we construct the green building, we should ensure that minimum 10% of the recycled content-based item of the total project value is being used, and also the locally produced materials. So that is also, we should ensure that we are using it in the building, and the permissible limit is 400 kilometers from the selected location. And also the wood what we are using, it should be approved from the FSC, and also the green building certificate material, we should try to use it when we construct the green building hospital. So this will, help us to sustainable, just to maintain the sustainability in the hospital. Indoor environmental quality and well-being. So in this, the minimum pressure ventilation need to be maintained on a continuous basis, and this has to be done as per the ASTRA standards. At the same time, when we maintain the minimum pressure, it should be ensured that it is as per the only control. It should not exceed the control. If you put more amount of pressure, it will increase the heat load within the building, and it will increase the air conditioning load, and subsequently the electric consumption also will go up. So that we should be more careful about the pressure ventilation arrangement. So the attached table shows the multiple numbers of the minimum outer air changes required per hour for the different care areas. Tobacco smoke control. So within the hospital, we should ensure that there is no any smoking, and we should strictly ensure that there is no any smoking at all inside the hospital. So we have to have the no smoking signages at different areas in the hospital, including from the entrance. Healing architecture through the daylight space. So more than 50% of the patient care area and other areas within the hospital, it should have the daylight space. And through that, we can increase the recovery of the patient and also reduce the patient stay within the hospital. So the attachment shows the natural light, what way we made the arrangement within the general ward and in the deluxe rooms and in the ICU area. Green open space, again, more than 30% of the free space, we need to have a garden actually, and this also will reduce the patient stay within the hospital. So likewise at the entry level, we can just consider the gardening. Ergonomic design, and it is mainly for the comfort and stay of the occupants within the hospital. So in this, the proper the spacing for the movement, and also the table, chair arrangement, and then the seating arrangement, the bed design, and the cardiac table movements arrangement. So everything, it should be patient friendly and for the people friendly. So this will definitely increase the efficiency of the workforce. And this is the ICU area, and it has been designed with the proper movement space. And for example, this is the OPD room. So in that, the doctor table, height, width, length, etc. has been arranged properly, including the chair arrangement. For example, here, if the chair height or the table height, if it is more than the requirement, then the doctor will not be able to do his duty properly. It will reduce his efficiency. So we should ensure that the proper ergonomic design is followed all across the hospital. And this is the corridor for the proper movement of patient as well as others. Stress relieving spaces. So within the hospital, we need to consider multiple numbers of stress relieving spaces like a dining area, gym, and then the space for the yoga, etc. need to be considered within the hospital. So the stress relieving spaces not only reduce the stress, and also it gives a good mind relaxation, and also it improves the people efficiency, whoever is working within the hospital. So likewise, we can have a good dining space for the staff, and separate dining for the doctors, and proper seating arrangement in the courtyard for the proper relaxation purpose. And the air quality monitoring and testing. So within the hospital, we need to properly maintain the temperature, humidity, VOC, particulates, and CO2. This all thing need to be continuously monitored and tested. We need to have a separate display in the common waiting area to monitor this on a continuous basis. In case of any variation, the action to be taken immediately to bring this all the level within the control limit. So the attached table shows what is the maximum permissible limit for the various factors. Sanitation and hygiene, it's all about infection control and for the waste reduction, municipal solid waste management. So in this, the general waste like paper, plastic, glass, metal, and cardboard. So this all the general waste need to be properly segregated and it has to be stored from the patient care area. And through the housekeeping team, it has to be properly and safely to be shifted to the general solid waste storage area. And from here, it has to be sent out through the pollution control board approved vendor for the recycling purpose. So through this way, we can reduce the general municipal waste. Instead of sending it for the landfilling, it can be send it for the recycling purpose, and through this way we can reduce the waste. And this is a general arrangement for the general waste collection area. Medical waste management. So in this, for the all the biomedical waste got a different color coding. The infectious waste got yellow color coded, and then the contaminated recyclable waste it got a red color coded, and then the sharp waste got a white color, and the broken glass got a blue color. So this all the waste need to be properly segregated and collected from the patient care area, and very safely this has to be shifted to the housekeeping team to the biomedical waste area, and it has to be segregated and separately it has to be stored, and from here it has to be sent out to the pollution control board approved vendor for the further recycling purpose or for the incineration purpose. So this is the general arrangement and the color coding for the biomedical waste. So this is at the patient room inside. So how we are segregating the biomedical waste, and this is at the OPD area. And also we need to use the organic waste converter within the hospital to collect this all the food waste which got generated within the hospital, and it has to be treated and it has to be converted as a manure. And this manure can be used in the landscape. So through this way, we can reduce the food waste which has been sent out of the hospital. Infection control within the space, the filtration. In the air conditioning unit, we have to use the pre-filters, micron filters, HEPA filters based on the requirement to treat the air which is coming into the indoor area, and through which we have to control the infection. And pressurization. So inside the hospital, various rooms got a various kind of pressure requirement. For example, the infected patients will be there in the negative pressure isolation room, and then the transplant or the immunocompromised patient, they'll be there in the positive pressure isolation room. So based on the requirement, the different kind of pressurized room need to be designed. So during the design stage itself. Antibacterial surfaces. So the high touch area like handle, etc. need to be designed with the SS316 for the antibacterial purpose. And also the high critical care area like OT, etc. need to be cladded with the antibacterial cladding for the infection control purpose. Sanitation design and cleaning process, the washroom in the OPD and IP areas, the proper design of washroom need to be maintained, the proper the design of water closet, wash basin, and then taps, and then health faucet. All this arrangement need to be there so that the user can use the washroom effectively for the infection control purpose. Also, the eco-friendly housekeeping chemicals, we have to use it within the hospital, and the cleaning protocol in the spaces. So in the hospital, we need to have a proper housekeeping SOP and as well as the cleaning schedule. And it has to be very strictly followed to reduce the infection control and not reduce the infection within the hospital. Energy efficiency, and this is the eco-friendly refrigerant. So in the hospital, more than 60% of the power is being used in the HVAC equipment. So the refrigerant which is used in the air conditioning unit, it should be CFC-free based type. The CFC-based refrigerant with a negative impact on the environment. So that we should go for the CFC-free based refrigerant to safeguard the environment. So in that R134A and R32, etc. So these are the CFC-free refrigerant and it has to be used. Then the minimum energy efficiency. So inside the hospital, we can use solar water heaters, BMS system, and then the energy recovery systems, then the proper LED lights, and with the high efficiency HVAC equipment. So these are things can be used to reduce the power consumption within the hospital. So in Apollo Hospital, Navi Mumbai, we are using VFD and then the automatic tube cleaning system in the condenser, also high efficiency pump and cooling towers, and then proper two-way valve as per the temperature requirement, and then high luminous with less power consumed LED lights, and also the timer-based operation in the OPD and in the administration area. Also, we are using solar water heaters for the hot water generation. Through this way, we can save the power inside the hospital, and the EPA approach method can be used to demonstrate the power saving within the hospital. So the Apollo Hospital in Navi Mumbai comes under warm and humid region. So in this, the acceptable EPA range is 275, and in the last calendar year, in 2023, so we could achieve our EPA value of 144.4 against 275. And the renewable energy. So in the hospital, the solar power and the wind power is generally used, as a renewable energy. So if the project is going to produce renewable energy within the hospital, so we have to produce minimum 1% of annual energy consumption of the facility. And if you are going to buy from outside, we have to buy minimum 25% of the annual power consumption of the facility. So here we are buying the power through the third party and through the group captive method. And in the last calendar year, so we have purchased almost 54% of the overall annual power consumption through the renewable energy, and it is through the wind energy. Water conservation. The rainwater harvesting system need to be installed within the hospital to collect the water during the rainy season and to treat it and to use it within the hospital. So this will reduce the municipal water demand. And also we can go for the rainwater harvesting chambers to increase the water, the table below the ground level. So this is a general arrangement of rainwater treatment plant in Apollo Hospital. And the water efficient plumbing fixtures. So when we select the water plumbing fixtures, so we should ensure that we are selecting the fixtures with the proper water flow, and we are maintaining the proper pressure in the water lines. So like water closet, urinal, hand wash, and multiple faucets, showers, hand shower, etc. need to be designed, and it has to be selected properly with the water flow. Through this way, we can reduce the water consumption within the hospital. So IGBC gives some certain amount of basic guidelines, and when comparing with this, Apollo Hospital Navi by reduce almost 25% of the water consumption from the base level. Wastewater treatment and reuse. So the ETP and STP, etc. it has to be installed for the wastewater treatment purpose. So the ETP is mainly to treat the lab related and the water from the biomedical waste area. And the STP is a sewage treatment plant to treat the entire wastewater generated within the hospital. And through these plants, we can treat the water as per the local pollution control board guidelines, and the treated water can be used for the landscape and for the flushing purpose, and including for the cooling tower water purpose also. Through this way, we can reduce the water consumption within the hospital. So as mentioned above, so this way we can properly select, we can plan, we can design, and we can maintain. Through this way, we can reduce the power, water, and we can reduce the waste and also the infection within the hospital. Thank you. Thank you all.
Thank you, Mr. Tulsinathan, for that very informative session. So the mantra for today is reuse, reduce, and recycle. So use, conserve natural resources, and energy conservation is the most important aspect. Thank you all for joining us today. I formally welcome you all to see you at 11th IPSC International Conference happening at Namma, Bengaluru. We'll see you soon on 23rd and 24th of February. Thank you, both the esteemed speakers. Thank you, all the participants. Hoping to see you all. If you've not registered for the conference, please look into the chat box. You have a link given and you can register from there. Thank you all.
Thank you, Dr. Ma. Thank you,
Thank
Dr.
you. Thank you, Dr. Ma.
Sir, and thank you to entire Apollo.
Thank you, Dr. Sanjay.
Yeah.
Thank you, everyone. Thank you so much.
Yeah.
Thank you, Dr. Sanjay. Thank you to all participants.